Okay, this is part 2. It's still Thursday morning, except for I'm going to try to go quicker on this one because I kind of spent a lot of time on the last one trying to get you to see the idea. We're going to be working on the surface area of pyramids and cones now. Same basic principle. The only thing that's different between a pyramid and a cone is that it only has one base. So it has one base, and we're going to introduce to you for the first time this thing called slant height. What do you mean height that's slanted over, Mrs. Williams? You always said that height has to be perpendicular. It does, but because a pyramid comes to a peak, and we said that pyramids and cones have sides that are triangular, because they come to a peak, this height of the triangle becomes slanted. It becomes leaning over. It goes from the apex through the middle of the side all the way to the base. And this is really a slanted triangle, but the height is perpendicular to the base that it's sitting on. So this triangle is definitely leaned over, and the height of that triangle is really from the base of the triangle to the apex. So it's called slant height, but that slant height really is perpendicular height to the base that it's sitting on. And just like the last video, I said there's two ways we could do that. We could find the area of one triangle, and we know that the area of a triangle is 1/2 the base times the height. And in this case, this height is this slant height. So 1/2 the base times the slant height. But then again, we would have 4 of these triangles. So then we would have to take the one triangle, and then we would have to multiply it times 4 in order to get 4 of these. And again, this base is this side of the square, so it would really be 1/2 the side times this height, which is the slant height, times 4. So we have 1/2 the side times the slant height, 1/2 the side times the slant height, but then we'd have to multiply it by 4 to get all 4 of these. Or we could simply say, hey, just like the last video, I could have the lateral area, which is all 4 sides, all the sides, the lateral area would be 1/2 the perimeter, which would be 1, 2, 3, 4, times the side, which is, times the slant height. That would give me my lateral area, 1/2 the perimeter times the slant height, which is very similar to what we did just a few minutes ago, except for we did the perimeter times the height. The perimeter of the base times the height of the triangle, but because they're triangles, they're 1/2. So putting it all together, we have surface area generically is lateral area, the sides plus only one base. And then we could break the lateral area down to say, hey, it's got to be specific for a triangle. And because there's 4 triangles, we now say it's 1/2 the perimeter, 4, times this height, which is our slant height, plus one base. And that base happens to be a square. So we could say length times width, or we could simply say side squared. Length times width, because that is the area of this base, or we could have said side squared because it's a square. So now we can go from a square pyramid, a hexagonal pyramid, whatever this base happens to be, we can use the formula for that base. So it's not much different. It's basically exactly the same thing, except for you only have one base instead of two bases. And this slant height comes from the fact that this triangle is slanted over. So we're not using the height in the middle, we're using the height of the triangles because the sides are triangles. I hope that makes sense. Then we have to remember that they don't always give us all the information we want. We have to kind of pull it out and dig it out. So if we look at this triangle inside of the pyramid, we can see that this height that goes from the apex to the middle is the actual height, but the height that we need is the slant height, which then becomes the hypotenuse of a right triangle. And if we look at the length of this base down here, from the center to the edge is really half. And if we were to double that half of that triangle, that small base, you would see it would give me one whole side. Because one side is from the center to the edge twice. So they're not always going to give us the information we want. They may give us the side of the square. Well, the side of the square is going to give me the perimeter. It's also going to give me the area, because side squared equals length times width. And because it's a square, we would have two of those. So side squared or length times width. And then it would be our job to find this slant height. And how do we find the slant height? Then we have to start thinking of a squared plus b squared equals c squared, which c would give us this slant height, a would be this piece at the bottom, and b would be the perpendicular height. Alright, so a square pyramid has base edges. Okay, first off, we know that the square pyramid has base edges of 5. So we know that the area of the base, because it's a square, is side squared, which would be 5 squared. So we know that the base area is going to equal 25. The slant height is 3. Okay, so how did we find the area of the sides? Well, that would be lateral area. And lateral area is 1/2 the perimeter times the slant height. So 1/2 the perimeter. Well, if it's a square and each side is 4, the perimeter is really 4 times 5. And then the slant height, they're telling us, is 3. So the lateral area, which is 1/2 the perimeter of the base times the height, is 1/2 the perimeter of the base, p, 4 times 5, times the slant height, 3. And we know that 4 times 5 is 20, 20 times 3 is 60, and half of 60 is 30. So the base area is 25 units squared. The lateral area is 30 units squared. So the total surface area, which is the sum, is the 25 plus 30, which is 55 units squared. Okay? What is the lateral area of the hexagonal pyramid to the right? We want to know the lateral area of the hexagonal pyramid. That is really, really cool because they're not asking me for the total surface area. I don't need to figure out what this hexagonal base is. All I need to know is what is the lateral area of the hexagonal prism. So, lateral area was nothing more than 1/2 the perimeter of the base times the slant height. Because we're dealing with triangles, we have the 1/2. We want the perimeter of the base because we need to know how many triangles are in here. So since the perimeter is a hexagon, we have 6 of these 36 feet sides. So we end up with 1/2, 6, because it's 1, 2, 3, 4, 5, 6-sided, and each side is 36 feet long. And we need a slant height. Well, looking at this picture, they give me a perpendicular height. They give me the base of this triangle, which is 18 square roots of 3. So what we're missing here is our hypotenuse, which is equal to our slant height. So then this becomes Pythagorean Theorem. Okay, so I want to stop and look and make sure you can see what I'm writing. All right. So we have a squared plus b squared is c squared. So we end up with 42 squared plus 18 square roots of 3 squared equals c squared. Now remember, square root of 3 times the square root of 3 is nothing but 3. So when we go to do our calculations, make sure you don't make it any harder than it is. Okay? So we end up with 42 squared. So 42 times 42 equals, I'm going to write that over here, 1,764 plus square root of 3 times the square root of 3 is 3. All right, and 18 squared is 18 times 18. Okay, so 18 squared is 324 times 3 gives me 972 equals c squared. Adding these together, we have 972 plus 1764 equals 2,736 equals c squared. Don't forget, take the square root of both sides. Taking the square root, we end up with 52.31. So this slant height is what we need, which is 52.31. And then we simply plug it into our calculator. We already have the 52.31 in the calculator. So then we're going to do times 6 times 36 equals, and take half of all of that, and we get 5,649, approximately 0.1, and we're dealing with feet squared. Okay, and then you have a cone. Same thing, trying not to take too long. Same thing, we have these cones that peak over to a point. This could be like a drinking cup if I turned it upside the other way. Don't forget the base of a cone. The base of a cone is a circle. How do we find the base area of a cone? Well, that would be pi r squared plus the lateral area. So we need the perimeter of the base times the height. Well, because a cone is slanted over, we don't need the perpendicular height. We need the slant height. And what is the perimeter of a cone? The perimeter of a cone is nothing but the circumference is my perimeter. So for the perimeter, we can substitute in the circumference, which is 2 pi r. So there is my formula. Lateral area is 2 pi r times the slant height plus the base area. So I want you to see that these formulas are very, very, very similar. They're exactly the same thing. They take into consideration that these sides really do look triangular. And like with everything we know, a triangle is 1/2 base times height, but the height of this is the slant height. So we want to take in consideration that. All right, the radius of the base of the cone is 16. So from the center to the edge is 16. Don't be afraid to draw a picture. The radius of the base of the cone is 16. The radius means they're giving me this distance. Its slant height is 28, so they're telling me I know the slant height. The slant height is 28. What is the surface area in terms of pi? Leave pi alone. That means do not convert. Leave it alone. So they're giving me everything that we need. All we needed is a radius and a slant height. Everything else we can find. So let's write the formula. Surface area is nothing but the lateral area plus 1 base. Because this is a cone, the lateral area has the shape of a triangle, which would be 1/2 the perimeter of the base, or the distance around, times the slant height, plus 1 base, which is a circle. And now let's give it specifically. Perimeter is the distance around, which is 2 pi r, plus the area of the base, which is pi r squared. Now this is really cool. On these formulas, you're going to find often that the first two are going to cancel each other out. What's 1/2 of 2? Well, the formula for the perimeter is pi r, 2 pi r, 2 pi r. If I take 1/2 of 2, that's simply 1. So these cancel out, and we simply have pi times r plus pi r squared. For the surface area, all we need to do is plug in the radius. They tell me the radius is 6. 16, I had it right to begin with. So the radius of the base is 16. So we have 16 for the radius times pi, plus pi r squared, which would be pi 16 squared. Back to the calculator. All we have to do is be able to square, 16. Stop it, stop it, stop it. Okay, 16 times 16 equals 256. 256 times pi. Leave pi alone, 16 pi. Total surface area is 256 plus 16. 256 plus 16. We have 272 pi. In terms of pi, leave it alone. Part A, what is the lateral area? Again, they only want the lateral area. We do not have to mess with the base. Total surface area equals lateral area plus 1 base. because we want just the lateral area, we do not need the base. With a cone with a radius of 10 and a height of 28. Be careful. They're giving you a cone with a radius of 10 with a height of 28. What do you have to find? Yes, you have to find the slant height. All we need is a lateral area generically, specifically lateral area for a cone because it represents triangles, 1/2. Because the base is a circle, the perimeter would be 2 pi r, and slant height is what we need. We need to find the slant height. So again, Pythagorean Theorem, 28 squared plus 10 squared equals c squared. All right, 10 squared I know is 100. And 28 squared, 28 times 28 equals 784. 784 plus 100 equals 884. Don't forget, we got to take the square root, hit the square root key, and we end up with 29.7. This time it says round to the nearest whole number. Do not round this yet. Actually 29.73. Let's go ahead and leave it to the hundredths. Plug it in, and then we round at the end. All right, so 1/2 times 2, these 2's cancel out, and we simply have pi 3.14 times the radius, which we ended up with 29.73. Actually, that's the slant height. The radius is 10. So we have pi, radius 10, and the slant height, which is 29.73. Multiplying that all together, times 10 times 3.14. Rounding to the nearest whole number, we end up with 933.58. This is greater than 5 or greater, so it's going to kick this whole number up to 934 units squared. All right, that's all I'm going to do today. I want you to see that these formulas are not difficult to use once you see them. When might I use just the surface area of a cone? Maybe if I want to see how much material I'm going to need to make that drinking cup, because in a drinking cup there is no base. It was kind of like my toilet paper roll. My toilet paper roll does not have to have any ends, so I would not have to cover that. If I was to take this and turn it into a cone, for drinking, say, you know what? It would be easier for me to do with a sheet of paper. If I was to take and make this into a cone for drinking out of, and it works better if it's a square. Come on, you've done this before. Let's just pretend this is my cone. I only need the surface area of the sides because I don't have a base, and then I could have a drink. All right, guys, love you. Have a good day. Lots of notes, lots of information. I'm going to give you lessons for today and tomorrow, and you have until Monday to finish everything up. Have a good one. Bye.